Ever wonder how casinos always seem to win? Or how insurance companies can possibly predict the future? Well, it's not magic, and it's not a crystal ball. It's a fundamental principle of probability called the law of large numbers. In this explainer, we're going to break down how this law really works. And I promise, once you see it, you'll start noticing it absolutely everywhere.
Okay, so to really wrap our heads around this, let's start with a classic puzzle. Picture a town with two hospitals. There's a big one that delivers about 45 babies a day, and then there's a smaller one that only delivers about 15. So here's the question. Over the course of an entire year, which hospital do you think recorded more days where over 60% of the babies born were boys?
So what's your gut telling you? The larger hospital, the smaller one, or would they be about the same? Go ahead, take a second. When researchers first posed this, more than half the people went with about the same. And look, that intuition makes sense, but it's wrong. And the reason why it's wrong reveals this fascinating glitch in how our brains think about stats. And the answer is the smaller hospital. Kind of surprising, right? So why is that? Well, it's because smaller samples have way more random swings, way more variability. In a small group of just 15 births, a few extra boys by pure chance can easily tip the scales over that 60% mark. But in the large hospital with 45 births, random fluctuations tend to cancel each other out, keeping the numbers much, much closer to that 50-50 average, day in and day out. This puzzle is actually the perfect setup for our main topic.
The big idea that explains this whole hospital puzzle is one of the most important concepts in all of statistics, the law of large numbers. This is the mathematical principle that brings a kind of order to what seems like pure randomness.
So what does that actually mean? Put simply, the more times you do something, the closer your results are going to get to the true average. Think about flipping a coin. If you flip it just 10 times, you could easily get 7 heads. That's not crazy. But if you flip it 1,000 times, you're going to get something really, really close to 500 heads. The short term is chaos, but the long term is incredibly predictable.
And you can actually see the law at work right here. This graph is showing the average sum of 2 dice being rolled over and over. Look how wild and all over the place that line is at the beginning, with just a handful of rolls. But as you keep going, see how it starts to settle down, getting closer and closer to that dotted line? That line is the expected average of 7. That's it, right there. That's chaos slowly turning into predictability.
So this brings us right back to that hospital problem. The math, the law of large numbers, tells us that large samples are stable and a good reflection of reality. But our brains have this built-in bias, this mental shortcut called insensitivity to sample size. We just naturally tend to assume that a small sample, like the small hospital, should behave exactly like a big one. We forget that small numbers are noisy and prone to these wild extreme results. So where did this huge idea even come from? Well, for that, we need to jump back in time, all the way to the early 18th century, to meet a guy from one of the most amazing families in the entire history of math. This is Jacob Bernoulli. He was a Swiss mathematician who was totally obsessed with probability. But he wasn't just interested in games of chance, like dice and cards. He had a much bigger vision. He wanted to use probability to solve real-world problems, civil, moral, and economic problems. All of his big ideas were eventually published after he died in this incredible book, Ars Conjectandi, or The Art of Conjecturing. But Bernoulli hit a major wall. He basically said, look, it's easy to figure out the odds of a dice roll because you know there are 6 sides. But how on earth could you figure out the odds of something complex, like the probability of catching a certain disease? He thought trying to figure that out from pure theory was just mad. It was impossible. And this wasn't some minor puzzle he thought about for a week. This problem consumed him for 2 decades, 20 years. He was desperate to find a way to figure out these hidden real-world probabilities, not from theory, but from watching what actually happens. He wanted to learn from experience, from data. And eventually, he cracked it. The absolute highlight of his book was his groundbreaking theorem. It was the very first proof of the law of large numbers. He showed with pure math that if you just observe something enough times, the results you see will get closer and closer to revealing the true hidden probability you were looking for all along. Okay, so a 300-year-old math proof? Why should we care? Because this idea, this theorem, became the engine for some of the biggest industries on the planet. It's all about how it lets us turn deep uncertainty into something very close to certainty. Let's take insurance. An insurance company has no clue if your house is going to have a fire this year. That is completely unpredictable for one person. But by insuring millions of houses, the law of large numbers kicks in. They can predict with stunning accuracy how many total fires will happen across their entire customer base. That predictability is what lets them set their prices and build a profitable business. Same thing for professional traders. They can't know if one trade will make money, but they can rely on a tiny statistical edge to be profitable over thousands and thousands of trades. So how does a trader actually find that edge? It's a super rigorous process. It's about finding some little inefficiency in the market, building rock-solid rules based on data, and then, and this is the really hard part, having the discipline to follow those rules over and over and over again without emotion, just letting the law work for them.
Now, with any powerful idea like this, there are always some common misunderstandings. And the law of large numbers is often confused with a very, very tempting but totally wrong idea.
I'm sure you've heard someone talk about the law of averages. You know, the idea that if a coin lands on heads 5 times in a row, then tails is somehow due to happen next. This is a complete corruption of the real law, and it's a mental trap we call the gambler's fallacy. And this slide illustrates the difference perfectly. The real law is about the long-term average over a huge number of trials. It doesn't say anything about predicting the very next flip. The gambler's fallacy makes that exact mistake. It incorrectly assumes that past events somehow influence the next one, like the universe has to balance the books right away. All right, so let's put this to the test. A roulette wheel lands on red 10 times in a row. A gambler watching this might think black is totally due and put a huge bet down. What is the actual mathematical probability that the next spin is black? It's exactly the same as it was on every single spin before. The roulette wheel has no memory. It doesn't know it just landed on red 10 times. It doesn't care. Each spin is a fresh start, totally independent of the past. That's the key. For truly random events, the past has zero influence on the future. So let's end with one last, kind of mind-bending thought from Bernoulli himself. He wrote that if you could just watch everything happen for all of eternity, you would find that everything in the world happens in fixed, predictable ratios. He concluded that we'd be forced to see a kind of fatality or destiny hiding inside the chaos. It's a pretty deep idea, right? That underneath all the randomness we see day to day, there might just be a profound mathematical order to the universe. What do you think about that?